Hi, everyone, and welcome to this special Waves webinar event, The Art and Science of Tuning. This webinar is part of our Waves 2021 virtual conference held in concert with CES this year. I'm Adam Levinson, Director of Marketing at Waves, and it's my pleasure to host this event today. Let's get started. Waves technologies make sound more rich and voices more clear on devices ranging from laptops to smartphones, headsets, much more. Our first step with any device is to integrate our technology, but that just gets us started. From there, our expert tuners use proprietary software to tweak literally hundreds of virtual knobs, sliders, buttons, faders to give the device that sound quality that we're aiming for. It's the tech, the algorithms that makes the great sound possible, but it's the tuning that really makes the sound come alive. Jack Joseph Puig, one of our esteemed guests today that we're very happy to have, once noted that one way to think about tuning a device is to visualize how an expert mechanic might tune like a Formula One race car. Ultra precise, mathematical, measurements, benchmarks, all of that's critical stuff. But the X factor is the experiential decision making. It's that subjective element, the artistry that makes it all come together. Now, in our webinar today, you're going to get a valuable overview of tuning, including a rare behind the scenes perspective into our philosophy, our technology, our process. Later in our talk, we'll even share a bit about our vision for the future. One of the fascinating things about this subject, in my opinion, is how tuning is at the nexus between the art of sound and the science of acoustics. Thus, the title for our webinar today, The Art and Science of Tuning. Now, I'm joined by very special guests. In Los Angeles, Jack Joseph Puig, multi-Grammy Award winner and our VP of Creative Innovation at Waves. You'll see that Jack is in his studio where a lot of our tuning takes place and a lot of hit records have been made. In Tel Aviv, Itai Naran, Director of R&D, the world-class technologists that drive innovation at Waves. And we'll be joined by Yucheng Chen, who will be joining us from Taipei, where he manages the Waves tuning team in our state-of-the-art studios. Welcome, everybody. Let's get going. You know, we have a diverse audience today, people from many different backgrounds. So what I'd like to start with are some fundamentals. This stuff might be basic to some people. It might be brand new to other people. And that's why it's all exciting. I want to get started with a really basic question for Itai. Let's get started with Itai. Why do we need to tune? What is being tuned? Can you give us some background, some basics?
Hi, everyone. Well, you might as well ask, why do we need audio processing? Why do we need to apply all these algorithms to the audio? Well, we mostly do it for the same reason we apply effects and audio processing in the recording studios and the mixing studios when we make music, movies, and broadcast. We are after two things mainly. We are after creating an experience to the listener, to pass an emotion, to make the sound immersive, to make the sound enveloping the listener, get more loudness and exciting bass, crispy air, high frequencies, punchy music, intimate voice, all these emotions. And there is another aspect, which is to overcome limitations. There are limitations to the microphones and to the loudspeakers that we are using in devices, also in the studio. And to overcome these limitations and the limitations of the acoustics, the environment, the noise around the device, we need the algorithms to compensate. So basically, we apply algorithms just before the loudspeakers, before the audio gets to the loudspeakers, and just a moment after the audio is captured by the microphones. These are the two sides. And so we apply over 100 of algorithms to enhance the audio for the two aspects of creativity and emotions, experience, and to overcome the limitations. And this is reflected by over 1,000 of parameters controlling all these algorithms. So with these thousands of parameters, we actually need someone to tune the parameters of the algorithms and get them to do what we want them to do. We apply algorithms to the loudspeakers. We need somebody to listen, to measure, to attend the quality that is going to be transmitted to the listener. And for the microphones, we need somebody to attend the quality of the voice that is going to be captured.
Okay.
And there are many methods to capture, attend the equalization of loudspeakers, objective methods, even automatic methods, or to measure the loudness of loudspeakers. But I'm not aware of many objective methods to measure a dynamic range compression, missing fundamental effects, punchiness of drums, clarity of voice, things like good stereo, directionality, stuff like that. I'm not sure that the science allows us today to quantify them unless a human is involved in a process. So,
okay, and it's not just a human, it's a human artist, a master tuner. I want to drill down a little bit into something that you said, a few words that you said. You said immersive, you said enveloping, you said exciting bass, and you said crisp, and all of those things are subjective. And I want to go to Jack and talk a little bit about how do we know what we're looking for? In other words, we talk about things like, exciting bass, but how do we know when we're there? How do we know what's good? How do we know what sounds great? And how do we know what will sound great to people using these devices? Can you give us a little bit of perspective?
Well, for me, the way I view this is really what we're talking about today is device mastering. That's really what we're talking about. And for me, in what I do, there are two important things for me. One is to create the right signature. So when I say signature, the audio signature for that particular company. If we hearken back and we think about some of the different manufacturers that we may even love to this day, and I'm talking about your particular personal choice, without saying any names, any of the different manufacturers that we all know, they have a character to them, some of them don't. In the past, they really had a character. You could talk about a particular brand and it had a certain feeling and a certain attitude about it, as we have with anything. In other words, a BMW is one kind of feeling and a Mercedes is another feeling. They're both excellent, but consumers choose different ones that fit, what they like. So creating the right signature for a company that we work with is on top of my mind, and making note of what that is and keeping that through the product line as they move on and grow, that signature exists. And then the second important thing would be honesty, that the device is honest. And it can never be exactly what the creators intended, as other companies have said, because that's next to impossible. You can't create exactly like they did because you don't have the same tools and the same systems. I mean, what I mean by that is a lot of how things are heard, and specifically, let's talk about mobile devices, don't have the ability to actually produce exactly what a huge monitoring system in a creative situation might be able to do, or what a monitoring system can do in a huge situation, in a huge recording studio, where you're hearing literally the lowest frequencies to the most highest frequencies. But what you can do is be honest to the mood and the feeling and the intent of what they were creating, whether that be in a film, whether that be in a record, whether that be in a game. It doesn't really matter. The device needs to be honest to every type of experience you as a consumer would want to listen to.
Okay, that's fantastic. So in other words, there isn't any general good sound. It's all about the signature that you're going for, and then trying to achieve this kind of honesty with the content on whatever device we are working with.
We have all been in a situation where we hear music. Let's just take music as an example. I know I did speak about every kind of content, but let's just take music for a minute. You can hear that in lots of different places and still connect to it, even if it's not exactly the best, what we would call the best sounding system, or what is better or what is good. What's important is to connect the person who's listening, the consumer who's listening, to that emotion and that feeling. What I'm pointing out with what I said a moment ago about the signature and honesty and how that relates to what's good or great sound is simply this. It is almost impossible for me to describe to you an aesthetic. What I'm talking about is an aesthetic. That goes way beyond frequencies, compression, equalization, any of these terms that all of you hear when people talk about device mastering. I am going for an aesthetic, a feeling. Way transcends sound.
So when you're going for that aesthetic, and you're presented with some of the realities of these devices, for example, the fact that they're used in a variety of different contexts and different scenarios, so there's different contextual situations that you have to keep in mind when you're doing this work. And then there's also the acoustic challenges of the device themselves. How do you balance all of those considerations when you're trying to achieve that aesthetic, but you're faced with these challenges? Like, you don't know where or how exactly it's going to be used. And you're also dealing with this, a laptop, which isn't exactly an acoustically designed device. What's your approach or your thoughts on that level? And Itay, you can jump in if you want.
So this is a very lengthy, really, you could do an entire masterclass just on that particular subject, period. But let me answer it like this. For me, the most important band is the mid-range, not the high frequencies and not the low frequencies. If we talk about a laptop or if we talk about a mobile device, that being any kind of smartphone, we realize that we have small micro speakers, which means that we don't have low frequencies and we don't have high highs. But I tell you what we do have, mid-range. We have the mid-range in the speakers in the ceiling at the grocery store. We have it on a mobile device. We have it in a car. We have it in the most amazing $5 million stereo system. Everything has mid-range. And mid-range reacts to every kind of environment. Is a phone, for instance, or a laptop on top of a hard surface, a soft surface? Is it in a live environment? Is it in a dead environment? All those things will affect high frequencies and low frequencies, but the mid-range will always be alive and right there. And the other reason why the mid-range is the most important is the mid-range is where the soul and the attitude of anything lives. The only time that the low frequencies really, really extremely matter, are, of course, in live concerts or in the club, places where the pelvic energy, for lack of a better description, is driven by the low end. But still, even in that case, it's the mid-range that's the intelligibility. It is the mid-range that is the connection between you and I, between your heart and my heart. What connects us is that mid-range. And how great that mid-range is the ability for us to connect. Now, the last thing I will say, final thing I'll say on this subject is, let's just consider that the mid-range is the widest band, right? If you look at all the frequencies, the rainbow of sound, the entire spectrum, that mid-range is the largest spectrum. It's the largest piece of frequencies that we actually manipulate and deal with. So the mid-range is key. It's the cry in the baby. It's the sound of the drums. It's the sound of the commentator. It is that mid-range that actually translates the emotion and the feeling.
That is so interesting, and I think a lot of our viewers will find that really fascinating because for many people, what you think of first is bass, right? People, maybe you could say over focus on low end, and then the next thing you think of is, of course, the high end. So it's fascinating to hear that perspective. I want to move on and from that really fascinating sort of philosophical conversation and talk really more on a practical level about how this work is actually done. Now, there's only so much we can say today because, let's be honest, the tuning process is a trade secret. But there's some things that we can say that can help our viewers to understand how we do what we do. And I just wanted to give Itai an opportunity to talk a little bit about the tuning console. What are the tools that we use in this process, as much as you feel comfortable in describing?
The tuning console is like the cockpit of the tuner. It's a collection of controls that change all the parameters that we want to tune. And it allows changing these parameters in real time. So the device is responsive in real time. The audio changes as you move the controls so that tuner can listen to the loudspeaker if a loudspeaker is getting tuned, or to what comes in from a microphone if this is what we're tuning. And the tuner is also able to see many gauges appearing on the tuning console. These are meters and analyzers that are monitoring whatever happens in many intermediate points inside the algorithms. So there is a full control to whoever is tuning to understand what is going on in each and every algorithm. Eventually, you save from this tuning control something we call a preset. And a preset is just a collection of many parameters. It can be thousands of parameters in one preset file. And in fact, in one preset file, there can be many presets, each addressing a different mode of the same device, different stream, kind of application, a different use case. We tune differently on the input, we tune differently to speech, automatic speech recognition versus voice. We tune differently to when you are close to the device versus when you're far away. At the output, we tune differently music and movies. Very, very different. Probably Jack can explain that. There's terribly many parameters which need to change between the two. So, and there are use cases. And so we save all this, we capture it in a preset, we ship it to the QA, of course, then we ship it to the OEM. And then the OEM evaluates those presets in real time with the device. And once it's approved, it actually ships to the end user, those presets. It's hidden in the end user's device. In stores, the user has no access to those presets, except for indirect access, where they actually manipulate user controls, say, I want more bass. And then internally, something crazy happens. Not only a switch of a preset changing hundreds of parameters internally, but sometimes things even change smoothly. They change gradually.
Okay, so I have a question. So Jack was talking about, achieving this audio signature in the tuning. If the end user has some control, does that mean that the original tuning is significantly changed? How much can the end user change the basic tuning?
Well, I think first of all, you need to. I would suggest the way to look at that is any system has a bass and treble control, to make it very simple. So all they're really doing is saying, hey, I want to hear more bass or I want to hear more treble. It's that simple.
Okay, so the fundamentals stay the same, and they're sort of tweaking around the edges.
The root stays the same. It's just a consumer may want to, for their ears, this goes back to the signature, for their ears, they just might want to be able to hear a little bit more highs or lows, for whatever reason. I'm simplifying it, of course.
So I had the opportunity to get together earlier in the week with Yucheng Cheng. We talked about the unique makeup of our tuning team. and our state-of-the-art sound labs in Taipei. The Wave Sound Labs include multiple purpose-built studios, including an anechoic chamber. How exotic does that sound? That's a highly specialized space with no reflections, perfect for tuning. Let's jump into my conversation with Yucheng now to learn more. What kind of training or professional experience, what kind of background do these people come from? I mean, were they born to tune? Tell us a little bit about where they're coming from and how they got to your team.
Yeah, that's a very interesting question. And actually, I wanted to use this chance to share with you about my team are actually comprised of a lot of experts on music post-production, and some of them come from ASIC design house. Someone comes from an ODM manufacturing background, and some of them are live musicians, and some of them are doing post-producing. I do feel the team, although they have a lot of variety of different background before they come to Waves, they all share the same passion to make the best sounding of their own and trying to sign their name on the device they tune. And
that's terrific.
Yeah, and actually we do have one mission to support the best consumer devices that we managed.
That's great. That's something that's really unique about Waves, right? Is that so many of us come from that content creation background, sound designers, even, DJs, turntablists, musicians, as you just said, post-production. I think it's really one of the things that makes the team so unique.
Exactly.
And it's not just the team that's unique, it's actually where you're working. I mean, I haven't had the opportunity to visit yet. I'm really looking forward to that. But I understand that our test labs where you work were designed
Correct.
By a company called PAL Acoustics, and they're an internationally recognized acoustic consulting company. Why is that important? And the labs have been only open for about a year and a half now, right?
Right.
So what makes the PAL Acoustic design important or significant?
PAL Acoustic is recognized as common certification lab for most of the audio and video industry standards, which they managed to handle most of the OEMs like Dell, like HP, some of the tier one PC branded customer, and help them to certify devices for Microsoft, for Amazon, something like that. We are happy that we had the chance to cooperate with PAL Acoustic on using their skills and experience, and mostly for the Simulink certification requirement, which may reintroduce some concern if the lab itself is not actually built by the certifier. It will create some other time to let customer worry on the performance alignment of our lab and real certification lab. So having the chance to cooperate with PAL Acoustic is an approach that we want to save time to market for customers.
Got it. Let's get back with Jack and Itai now. And I wanted to throw it back to Jack. Coming from your background in music production, are there similarities between, tuning consumer devices like laptops and smartphones and making hit records? What's the connection there? Can you give us some perspective?
There are a lot of actual connections. In the same way that as a record maker, as a content creator, one of the things that we do as we go along in our career is we create technique. Now, the thing about technique is it's actually unnatural. Technique is not natural. But if you develop your technique, the most beautiful thing about it is it starts to become second nature. The object is, how do I create my technique and systems, but where it becomes second nature, where I don't even have to think about it, but actually it improves my ability to do what I do. I really honestly have to say that I feel that being a creator and being in the creative space, my ability to understand what the device should sound like is beyond important. Because effectively what we're talking about here is the device is none other than rendering, playing back what creatives make. If you're a creative and you work in those spaces, you know what it's supposed to feel like because you baked the cake. So you know what the cake should taste like.
Right.
So it's extremely important for me as I hear things that maybe something I created or friends of mine created, and I know what the intent was and what it's supposed to feel like and what it's supposed to make you feel like, you as a listener.
So you're talking about that creation to appreciation kind of flow. Sometimes we call it creation to consumption. The connection between, or the knowledge of the content creation process brought into the tuning process.
Well, when you're in a creative situation, to be very good at what you do, you're consistently aware of everything that's transpiring in that environment. And you're reading every aspect of it. And how that relates to what we do when we're working on device mastering is learning the difference between hearing and listening. Our minds play games on us. And sometimes we have to ask ourselves, what am I actually, not what I'm listening to, but what am I actually hearing? What is the device telling me? The acoustic design, the transducers that are in that design, the acoustic makeup of that design, everything about that. What is it telling me and how should I react to it? And how can I make it sing? And actually even learning what's internally in them. Different kinds of silicon sounds different ways. Different kinds of transducers by different manufacturers have certain personalities. And you learn what those all are, just like in a recording studio, you learn what certain drums sound like, what certain guitars sound like, what a certain violin sounds like, what a certain room feels like that you're recording in, or a recording console, or microphones. All those tools, you learn what they sound like and what they do, so you know how to manipulate them and how to place them properly. That applies to consumer electronics as well. One vendor over another vendor, well, I'll leave nameless, all have their personalities. Different companies sound different ways, and I know what they sound like, and I know what they're supposed to sound like. So it's exactly the same application of what's in the recording studio can be moved and used in consumer electronics.
It's fascinating to hear you talk about that, because I think for a lot of people, we think about technology as being almost sort of like inhuman in a way, and you're talking about this truly human element that is involved in this process. I mean, you're talking about deep experience and like you said, technique that comes into play. Thank you for that perspective. That's terrific. We had talked with Yu Chang about this whole sort of like subjective, objective balance in this decision making, and about how voice assistants like Alexa and Cortana and video conferencing apps like Teams have these very specific requirements for tuning. This is kind of the other side of the coin from the art of tuning. This is more of the science. The whole purpose of these requirements is so that Alexa responds quickly and accurately to your voice commands, and so that we all sound good on a Teams call. But ultimately, meeting these very specific benchmarks, it isn't enough, because the other side of it is what you just talked about, Jack. The device needs to sound great. We need to achieve that signature sound, and at the same time, meet all of these benchmarks and these objective requirements. So let's listen in a little bit to our conversation with Yucheng now and learn more about that whole other end of the process?
So for VoIP, Teams is a classic example. And for another domain, like speech recognition engine, like Cortana, like Alexa, which is recognizing people's voice to give them their desired answer. People talk to machines, and we let machine better recognize what the talker is talking. For PC to recognize, to the surface behind the PC to recognize. So wave processing for every PC that we tune with, we make this PC easier to recognize and achieve the high accuracy and low false rate for the surface to recognize what is wrong and what is right.
So
Yeah.
it sounds like you need to do a lot of hard work to achieve that kind of accuracy.
Yeah,
Does that ever impact your subjective decision making? Like in the end, it has to sound really fantastic. What's the
Sure.
dynamic between sounding really fantastic and that kind of accuracy that you're talking about?
yeah. First of all, for subjective requirement that we wanted to do, it is also defined in Teams during one of the process for the end-to-end test.
Okay.
And for third-party testing, following the rules that Microsoft defined, we probably need to handle not just for objective, but the same PC has to follow subjective testing
Okay.
handled by
So that's-
Microsoft certified members. And we have to, the same tuning when we have to adopt on the same device. Actually, like you said, we do meet some classic like loudness issues where the teams has to certify in objective manner and constrain their nominal volume in certain level. But this constraint on objective defines the loudness. When the teams call play back the sound from the foreign talker. So
Okay.
this is actually limiting the cases where the certification itself has to be addressed. If the loudness has to be loud enough, it relies on capable echo canceller mechanism, and which we believe we had made some achievement on certain PCs to reach as loud as possible, and also make the echo canceller or duplex questions, single talk or double talk issues, much more robust against
Got it.
talker loudness.
I see, because that's one of the classic balancing examples. It's like you want it to be loud, but you don't want it to be so loud that you get echo cancellation problems.
Yes.
Waves is a pioneer and market leader in psychoacoustics, perceptual and adaptive technologies. And these technologies can influence tuning in real time, including bass enhancement, treble enhancement, compression, limiting. And I think it'll be really interesting for people to learn about how those kinds of technologies, psychoacoustic, perceptual, adaptive, interact with the preset tuning. And I want to hear a little bit from Itai on that subject.
Well, listening to a device like a mobile phone is challenging. You're like in the worst situation because the loudspeakers are just too small to play the bass you want to hear. They're too inexact to play the treble you want to hear. And they are hidden behind the touchscreen and the device compartment, so that you cannot get the directional sound that you want to hear, like good stereo sound that you would have in your stereo system. So it's a big challenge, and it's all about limitations. So there are two tricks to deal with limitations in the science. One is to understand the use case. And we know that we just cannot push the loudness that high. We know that without creating distortion, we know that we cannot play the bass we want. So we need to create some kind of compromises which are based on use cases. For example, if I'm listening to music, there are certain aspects which I would like to focus on and make them pop out. Whereas when I'm listening to voice, for example, maybe I prefer intelligibility or clarity. So every other different use case presents a different preset and a different solution. Now, here comes in the psychoacoustics. Psychoacoustics is very interesting. It's the science that gaps between the emotions, perceptions, and the intuitive tuning and the science. It describes how we hear things. So we know, for example, that there is something called masking. There is temporal masking, where things mask each other in time, and there is frequency masking, with things, some partials of the sounds hide each other in frequency. So we can make use of these aspects, just like we make use of them in professional audio plugins, and they are part of the music creation. We tried to mask the problems. So masking the problems, for example, I want to raise up the level in my tiny mobile phone, and I'm creating distortion. Actually, you just take any micro speaker and play a piano solo on it, any sequence you can play, you'll always hear some distortion. There's just a lot of distortions with these speakers. But we have tricks, and we can hide this distortion and get it masked. So then we can bring the level up. So if we know what is getting played, we can adapt to it and create more bass. For example, we can rely on a phenomenon called missing fundamental. So there is an effect which we have patented called the max bass, where we generate a sequence of tones from every frequency, which makes you think that you're hearing bass, but you're not hearing it. So this is one of the ways through psychoacoustics to get over the limitations, the hardware limitations.
So you mentioned, bass enhancement. You mentioned controlling distortion, and my question is, kind of going back to what we were talking about earlier. Do those real-time processes change the signature sound, or do we maintain that signature sound and we're just sort of adjusting around the edges again?
So an effect like max bass needs to be tuned to a particular device. You need to plot the frequency response of your loudspeaker and see where it can get. And then you will need to match the parameters of max bass to that specific loudspeaker. And the variations that are going to happen according to content are sometimes more or less, but eventually there's physics that you cannot win. There's a certain frequency below which you cannot play. This is where you want the effect to happen. There is another aspect, except for tuning, what you described is adaptivity. You want to adapt to the content. There are two ways to adapt to the content. You can make an automatic algorithm which detects the content and changes the sound, or you can tune presets in advance which relate to specific kind of context and switch between them. The nice thing about preparing presets in advance and switching between them is that you control the process very well. You can tune with very good sound engineer's ear to every use case, and all you have to do now is to detect the use case and switch the preset.
Interesting. I want to follow up with that and talk a little bit more about this concept of sound intelligence. In fact, this webinar is part of our Waves 2021 virtual conference held in concert with CES this year. And our theme for the show is sound intelligence. And our vision for what that means is on the fly sound adjustment, kind of like what we were just discussing. So here's my question. together with the rapid adoption of machine learning to drive algorithms, there's this real momentum behind AI, behind automation. It's clear, not just in audio. There's momentum behind AI in virtually everything. How do you see our approach and process changing as AI and related kinds of intelligence become more prevalent, and frankly, devices become more capable of a kind of self-tuning or auto optimization, you might call it? Itai, can you give us some perspective?
So, artificial intelligence is really cool. It reveals a totally new set of algorithms. Some of these algorithms are able to capture the scene, analyze the scene, and understand the context. This is very important because if you're listening to something that is deep in noise, it's very different than the tuning that you want to apply when there is no noise. And if you capture the scene and you can classify what the use case is, you can switch automatically between other algorithms which are intended to do the work. One of the interesting things about noise reduction, for example, noise reduction is very strong in artificial intelligence through neural networks. But there are use cases. One use case, I'll be talking to you through a voice over IP, and all the music that is in your background playing out through your TV set, I want to get rid of it. I don't want to hear it in our conversation. So this is music, I want to get rid of it. But then when I'm listening to music, I don't want the same algorithm to clean the music and get rid of the music. So the same algorithm needs to tune itself in context awareness and adapt itself. And this is AI. This is what it needs to do. You still need to tune the noise reduction algorithm so that it does good job. It doesn't get rid of too much high frequencies, too much low frequencies. And you still need to tune the music listening experience. But then you can switch flawlessly between them.
In other words, what you're saying is AI performs a quality-changing kind of role. It's going to add a tremendous value, and it already is. But it will never take over the kind of artistry that's involved with the tuning process.
I was talking about the present. Now, the future is there in the stars, and we cannot predict the future, but certainly AI systems take over more and more human jobs. Maybe one day it can take over the tuning jobs. But right now, since the music, voice, and especially movies are intended to be consumed by people, what you really want in your path is somebody taking care that this is good for consumption by people. So there is still no neural network that will tell you that this is good for people. You need a person to say that today, maybe in the far future.
That's terrific to hear. To hear that human element is going to remain important, and the creative vision that somebody like Jack brings to the table is so relevant and so critical to achieving the quality of sound that we're looking for when we integrate our technologies and do this tuning process. I want to thank you guys for joining me today. Thanks to Jack, thanks to Itai, thanks to Yucheng for sharing all of your expertise and insight today. That was fun, and I hope it was informative for the audience. Thanks again, and Happy New Year to everybody.